Hello everyone, welcome to my channel Crazy Physics. Hope you are all doing well. And now I will proceed to the part JK flip flop. And in the previous video, I have taught about the SR flip flop. Okay, SR latch mainly. So SR latch was the one of the basic latches. So those are modified, and then it was used as a modified flip flop. Okay, so that latch has been modified to a flip flop now. Okay, so what are the main points to ponder for the JK flip flop is that one is this name came from the two inventors Jack and Kilby. Okay, so those are the inventors of the JK flip flop, and which is the modified version of the SR flip flop. Okay, set reset flip flop. Why we need to modify the SR flip flop to a JK flip flop? Because we know that in the SR flip flop, when both the inputs of the set and the reset were same one up, okay, so then there is a invalid output was there. Okay, so that means that if S and R both are high value 1, then it will give invalid value. Okay, but in JK flip flop, it is it what happens is that the both the outputs of the flip flop gets complemented to each other. Okay, so when J and K both the values are up 1, then it will be the outputs will be complemented and there will be a valid output. Okay, so that's why we had to modify the SR latch to a JK flip flop, but it has a condition called race around condition. Let's see what is race around condition for that. So before going to the race around condition, I had mentioned earlier in my previous video about the clock pulse, which were been introduced to the SR latch to become a SR flip flop, so that we can get the outputs where the clock pulse is high. Otherwise, it will not giving the output. It will show only the previous outputs. Okay, so that clock pulse is coming in this race around condition also. When clock pulse is too long, when clock pulse is too long, CP is too long, clock pulse, then what happens is that if there is a J equal to K equal to 1, when the both the inputs are up, then what happens is that the outputs Q and Q bar, both the outputs become toggled between each other. Okay, so what happens is that when first let's say it comes a value Q, it comes a value Q bar, next moment it again goes to Q bar and in Q, then again Q to Q bar. So the complements are toggling between each other. Okay, so when clock pulse CP is greater than propagation delay, then what happens is that a race around condition occurs. In that condition, both the outputs of the JK flip flop toggles multiple time. Okay, so let's see the circuit diagram of the JK flip flop using NAND gates. So this is the required circuit diagram using NAND gates of the JK flip flop, and J and K are the two inputs and Qn and Qn bar are the two outputs, and there is a clock pulse introduced here, and from the circuit diagram it is confirmed that this is a sequential circuit. Okay, so it is mainly depend on also the previous outputs. Okay, so let's see about what is the truth table of this whole thing. Okay, when clock pulse J K Qn bar. Okay, So when clock pulse is 0, there is no clock pulse, so inputs are not anymore important. Then they will show only the previous values. Okay, previous values. Now when clock pulse is given 1 and the outputs are given 0 0, it will again show the previous values. Okay, next when J is 0, for these cases CP clock pulse is 1. Okay, so this J0 K1, then it will be 0 1. It is then reset condition. And then when J is 1, K is 0, it will give 1 0. This is set. And when both the inputs are up, then it will give Qn gives Qn bar, Qn bar gives Qn. So the outputs are complemented. So we are getting a valid output using this type of circuit other than doing SR latch. Okay, so that's why this is very much helpful more than the SR latch. So let's see what will be the characteristic equation of this circuit. Okay, so the characteristic equation is like such a thing, is just like the tense in English grammar: past tense, present tense and the future tense. We have to rely on the past outputs, and then we will give a present input, then we will show what will come as a next output to us. Okay, so when Qn is 0, past output was 0, both the inputs are 0, then it will show 0, which is the past value. Okay, when it is 0 and it is 0 1, it will give 0, which becomes reset condition. When it is 0, it is 1 and 0, it will become 1, which will be set condition. Okay, and when again is 1 0, it will keep the past value. When past values are 1 1 1 and 1, what will happen? So for 0 0, it will give the 1, which is, this is set value kept. This is again show the past value when 0 0. When it's 0 1, it becomes 0, so it is reset condition. When it is 1 and 0, it again becomes 1, which is set condition. And when both the inputs are 1, then it gives its complement. Okay, so this is the characteristic equation table. From this table we can generalize the equation as Qn plus 1. The next value of the output will become Qn bar j plus Qn k. This is the characteristic equation for the JK flip-flop. For once again we can discuss it through a equation. We know that Qn plus 1 for SR flip-flop is S plus Qn R bar. Okay, and we know that S is called JQN bar and R is known as KQN. Okay, so if we put the values in this equation, it will give JQN bar plus QN KQN bar. From this equation we can get to this one. It will be a mistake. Qn plus 1 is S plus QNR. So this will give this one. Okay, so there is no bar and Qn into Qn will be Qn. So that will be KQN. Okay. So next we will last discuss about the toggle flip-flop. So let's draw the diagram of the toggle flip-flop. So this is the required circuit diagram of the toggle flip-flop, where both the inputs are same one and the outputs are Qn and Qn bar, and clock pulse also there. Okay, so we will then discuss about the truth table and the characteristic equation for this circuit also. Okay, same as the previous. So what will be its truth table? So when clock pulse is 0, there is no input for toggle, so the outputs Qn and Qn bar will show the previous values. Okay, when clock pulse is 1, toggle input is 0, it will give the Qn and Qn bar, again the previous outputs to be hold, and when the input is 1, the outputs will be complemented to each other. Okay, so finally we will discuss about the characteristic equation of the toggle flip-flop. Okay, so for characteristic equation, to find the characteristic equation, we again rely on the tense system: past output, present input, and the future output. So when there is past output is 0 and the present input is 0, the next output will come 0. Again, when the past output is 0, toggle gives 1, it will give next value 1. When again it gives 1, past value was 1, toggle is 0, it will keep the previous value 1. And again the past value was 1, toggle gives 1, it will become 0. Okay, so can you say what will be the logic gate to get this kind of output? This is XOR gate. So the characteristic equation will be Qn vector sum toggle, which comes Qn bar T plus Qn T bar. This is the required characteristic equation for the toggle flip-flop. So this is the flip-flop part. Next I will start about the counters and most probably the shift registers based on the requirements. Okay, so till then, stay tuned to my channel and please subscribe, share my channel. Thank you so much for watching.